you may have seen in some of the other videos what the kit looks like, and I can show you that again in a minute with images, or we're right here in the shop. But the essential plan here is that students will get a bike kit. It's a box with all the parts and tools needed to build a fully functional mountain bike. And during that process, they will learn STEM-based lessons linked to the bike building process. And here they are, starting right out of the gate. The first thing that they will do is they will open up their frame and they'll examine their frame. And then we have a series of lessons. All of the blue lessons are engineering lessons. The red lessons are mathematics lessons. Green are science, and yellow are technology. And those are all standards-based lessons using the next-gen learning standards written by teachers and professionals in the fields for kind of the next wave, the needs or the assessed needs of students going into the workforce for the modern needs of the workforce. So you'll notice there's a couple other lessons. We have a purple lesson here and a purple lesson here. Those lessons are actually, call them language lessons. We dive into concepts like how the word systems has different meanings based on the context that it's being used in. It has a different meaning in, say, science class as it does in an engineering class. Or how this lesson down here, technical synonyms, how you can describe effort and resistance as input and output when you're applying it to a technical system. So we really dove into this. It's been incredible this summer to see these teachers, these 4 teachers, take what Haley and Bob and I had built early on and make it a real cohesive series of lessons that not only link back to the bike building process, but that also link to each other and support each other. And we now have a very a linear series of learning, but that's building on the system of the bicycle and the building process while the students are actually, while they're learning. And I did a fair amount of research before we even got started on this, on different methods of teaching. And we looked into a lot and read a lot about the systems approach to education, and found that very interesting because it's very applicable to what it is we're trying to accomplish here. And we were really able to, since we're building this program from the ground up, apply that. And we really feel that students will come away not only with a great understanding of concepts, but how these concepts interact with each other and how they work together to form the full body of content that is STEM overall. So, you know, it's very impressed up to this point, and I can't wait for I'm gonna let the teachers soon share with you what it is that they've been writing. But while I have this out, are there any questions, David, Cricket, or Jim? This is updated. Is there anything when you had a chance to look at this that maybe I could answer?
No, I think, you know, frankly, it wasn't, it wasn't really until I saw the mind map that I really, this all clicked with me. It's actually an admission. It's a confession. It may sound stupid coming from someone that's been involved in this stuff for a while, but it really brought home to me the connection, and then trying to go back too many years and imagine that I was looking at something like this as a young student. Would it be of interest to me? And it would have. It kind of brings the element of, as an engineer, you know, why am I studying this stuff? Well, the why I really had to find outside of the classroom. This brings the why back into the classroom.
I really believe that. I do. And it's just to follow up with what you're saying there. We think about that a lot. We actually had, you know, like bringing in Haley, who's just fresh out of college, or we actually had a couple of high school students engage with the program early on to give us feedback. And that idea of like, well, why am I learning this? That was so important in the writing process. As was ideas like, keeping our videos short and engaging, and using imagery as often as possible, and linking terms back. So we really have the student in mind. And
Right.
I'm just glad to hear you say that, David.
No, absolutely. I'm looking at the mind map. Was not initially when I first pulled it up, when Jim sent it over, I was like, whoa, okay. So then you have to come back and take a look at it, for me, bits and pieces. But I know Jim knows my background is in education. I work with Project Lead the Way for several years. So when it comes to project-based problem solving, hands-on learning, again, that's near and dear to my heart. And this just breaks it down so neatly into that, so that you can specifically see where all that learning by doing fits in so nicely. So great job.
Excellent. I'm glad. I hope it makes sense. I know it is a lot to look at, but there's a lot to the program. And so that's, it makes sense. We're looking at between 32 to 38 hours is our estimated amount of time right now. That's updated on the amount of time each particular module has been taking. We just recently filmed a student building the bike. And so that gave us some feedback about how long those parts took. And it was great for us to see, like, where were the challenges that this person had? How do we maybe alter our video content to help them with the building process, but not give them too much that they're not troubleshooting. And so that's been an interesting element to solve is, well, we want them to have to do a little troubleshooting, obviously. And so we've come up with a way to have almost like pathways within the building process, where if this happens, and like we're going to show a video where it just happened with the kid doing it. He was undoing a bolt and the parts of the bolt fell on the ground and he kind of looked like this. And I was like, that's perfect. If the video is going to stop right there, if this happens, you go this way, you take this link. If it didn't, then you move on to this link. And then it moves them in slightly different directions in the building process. And I'll tell you what's been absolutely amazing to me is, and this is what my vision was, but not being a STEM-based teacher. I'm like Cricket. I'm a physical education teacher, but I'm just avid about bikes, and I love this stuff. The way that the teachers have brought this content back, so that way the students. Oh, and the order matters, by the way. I don't know if it's clear in the mind map. In fact, it's kind of not. I almost wish I had built it upside down. The students do the STEM content first, and then build that part of the bike. And the reason for that, and there's a pretty good amount of research behind it, is that while you're doing the hands-on, your mind can then reflect back to the content. So like, for example, when we talk about, Hooke's Law and some of the strength and structures ideas, then they're working on the front end of the bike and they're putting those on. Those concepts are being applied during that building process, and they're actually seeing what it is that they just learned in real life. And research shows that that's just the best way for that information to sink in. And our hope is that every time a student rides a bike, sees a bike, hopefully rides this bike after it's been built, because it is a fully functional, quality mountain bike, that they're pedaling and they hear that click of the chain and they think, oh, that's we have a ratio change in our gears, and that's changing our output based on the amount of pressure. All these concepts I think are just going to stick. So sorry, tangent. I get really excited about this stuff. Any other questions about the mind map that I could answer? Okay, cool. I will move on. We had the one-page doc. I think it's just kind of an overview. That's probably pretty obvious there. But how about the video?
Is that for distribution yet? The one pager? I thought that was really cool. If I could be able to share that with my colleagues, that would be something they'd be interested in seeing.
Please share. That to me is kind of like this is the intro to explain what it is that we're doing.
Okay.
Get it out there. Thank you. I appreciate it. That way just more people can kind of, because it is like David said, what is this thing? What is it you're really doing there? It's a lot to get across. We do have the promotional video. That's another thing that I try to send out that I think goes well. And it's a rough cut, but we made that pretty early on. But those are the two items I think that if you're introducing this to someone for the first time, the one pager and the promo are probably the best way to describe what we're working towards. How about the videos of the bike building process? I don't know if I should show them again, or Cricket or David, did you want to see them, or did you just have any questions?
I actually did not get a chance to, I saw the promotional video, I saw the mind map, but the, no, it would be helpful if you want to show an excerpt of that.
No problem. Here's what I'll show is a building video, which is just, well, I'll start with that. Let's get that going there. Let's see. Boom, boom. We'll do that. Okay, everybody's seeing this here. It does not have audio yet. So this is one, before I get going too far here, everything's broken up into modules. And then the modules have 3 or 4 or 5, depending on how many parts are put on and how technical it is, individual videos that range from 1 to 3 minutes. We try to keep the videos short because there's a lot going on. So this is mod 3 crank assembly, and this is just the setup to start the process. So it shows them which part of the bike they're building. There is audio dialogue, but it just hasn't been, we're saying that's the last step of the process. So they're seeing what it is that they're putting on, what part they need, parts they'll need to get this done. So they know what to take out of the kit. That's the grease, the lubricant, and we're actually changing the lubricant to a tube instead of packets. And this is simply just setting up the bike for this process. So it's a nice short one. I thought it was easy to share. So I can show you one that has some actual building in it. I think I just picked the next video of him installing the crank. Everybody seeing this?
Yeah.
Good. And there's some dialogue explaining, why this one, what parts you need. Before this, we go into what a Newton meter wrench is and why a rated Newton meter wrench matters in this process. Describing, the audio will describe where it is, what's going on there. And then, and so this is all basically raw footage at this point. It's only had a little bit of editing. We're going to be combining in video of the student building to show where there may, like I said earlier, where there may have been like a troubleshooting scenario that needs to be solved. And actually, I'm realizing this now. You'll notice he's using a different wrench. We ended up changing out the wrench, which wrench we use, and we ordered new wrenches to go into the kit there. So that's that. And then what I can show you that does have audio is here.
Hey, Jake, refresh my memory. This is what age group are we talking about here that we're targeting?
High school level. This is a high school level process, and also freshmen in college. So we have an agreement with Hudson Valley Community College for their mechatronics and manufacturing program. They're going to be using this as a 100 level course for students to review their STEM concepts that they learned in high school, or if maybe they didn't take class or tech class, introduce some of those concepts, and also it's going to be a lab credit as well.
Awesome. Good.
So now I can show you one that does have some audio. It's the introduction to the program. And this is with our actress, Chelsea. And what you'll see on this one, if you see where these 4 dots are, those are each H5P interactions that are embedded into the videos. And again, this is a rough video, but I wanted to show you. This is where, and the other video doesn't have them yet, where students are asked to stop in the middle of the video and actually engage with the content. And you'll see how that works in a minute.
I will be your guide on this journey of exploration and creation. With our help, you will be a collection of parts, and I'm a member.
Good to begin.
My name is Chelsea, and I'm a member of the apparatus development team. I will be your guide on this journey of exploration and creation. With our help, you will turn a collection of parts into a fully functional, state-of-the-art mountain bike. This bicycle is fully equipped with hydraulic disc brakes, air shock suspension, and an 11-gear rear derailleur. Now, you might be a gearhead who's already super excited about this project, or maybe bicycles are not yet on your list of interests. Maybe you've been building things with your hands your whole life, or maybe you've never even used a screwdriver before. No matter your interests or experience, the team at Apparatus Development is confident you will find this process enjoyable, educational, and ultimately successful.
So here's an interaction. This pops up and the video freezes. What will you be building with the help of Apparatus Development? And we're going to choose the right answer, state-of-the-art mountain bike. And if we choose the right one, it allows us to go forward. You also build and expand your knowledge of science, technology, engineering, math. This is true or false? This is true. So these are real simple interactions. There are more complex ones. And I can't remember what else we put in. We'll see.
Building a bike is no small feat. The bicycle has 200 years of innovation built into it, and since its initial invention, has developed into some of the most effective and efficient pieces of engineering in history. Putting one together correctly requires coordination, dexterity, patience, and like any valuable task, focus and effort. No matter how much experience you may have, this isn't something you can skate through or cut corners on. You have to commit yourself to this process if you want to be successful. But don't worry, I'll be here to help you through every step of the way. You can do this. Are you excited to get started? Good. But first, there are a few things I want to share to help you be successful. Have a designated space for building the bike, one that isn't cluttered with other things. Clear out an area in a garage, basement, or dorm room just for this purpose.
There's
you
our
need
student.
a table or a flat surface to lay out the bike parts and tools, safe from food, moisture, pets, and little kids, where the bike materials can live while you work on it and when you walk away.
So keep bike safe. I got to do a little drag and drop on this one from little kids, from moisture, pets, and food. And then it'll check. If I got it right, I get to go forward.
Clear your device of clutter. Whether you're using a phone, tablet, or computer, turn off all notifications when you're at work. Make this app the only one you can see, hear, or interact with when you're working. This will help keep you from getting distracted. Don't stop mid-module. How long each module takes will vary for different types of learners, but stopping in the middle of a task is a bad idea. If you have to stop in the middle of a module, go back and review the first part before you pick up where you left off. This program is designed to help you succeed, so use it to your advantage. It's good practice to finish something when you start it, so get into the habit of completing each module before you walk away. Review what you saw and did, especially if something doesn't make as much sense as you like. It's better to be 100% certain you did something right than to move forward unsure of your work. If you don't, it'll just make you question your next steps and ultimately slow you down. There's nothing worse than having to go back and redo a bunch of parts because you forgot something. So take the time to check your work.
If you aren't 100% sure that you did a step correctly, you should go back and check your work. Nice, simple one, just to make sure that they're paying attention and staying
lastly,
engaged.
Ask questions and seek answers. Write them down as you go. You can ask an instructor, a family member, a classmate, or better yet, research the answers on your own. Asking questions is a sign of a good learner who is engaged in the learning process. The only thing better than someone who asks questions is someone who takes an active role in finding the answers. If you follow these tips, I am confident you will come out of the other side of this experience feeling like it was a valuable, productive, and enjoyable use of your time, and you get to ride this sweet bike. Let's set up and get started. Designate your building space, put your device where you can see and hear it, and get your kit.
Knowledge check. Choose the correct statement. STEM cycle and apparatus development will help you build a golf cart. No, it will help me build a bike. I've got more of them. Building a bike requires coordination, focus, and effort. Building a bike is pretty simple. No, we got that. Choose the correct statement. Have a designated space for building your bike. Definitely. And clean your device by turning off notifications while you work. Great idea. And choose the correct statement. Don't stop mid-module as opposed to taking frequent breaks. Good. More quickly and keep going because building a bike is time tested. Review what you saw and did. Check your work. And oops, scrolling down a little bit. Ask questions if you need help. Always a good idea. And it looks like I got them all right. Keeps them all up there for a minute, which is nice. I like that. And that is it for that one. So again, that's still rough. It needs a little work. I might decide 4 minutes is a little on the long side for us. I might decide to break that up into 2 videos. But honestly, with Chelsea delivering the lessons, like she's so good on camera. She grabs your attention. I think she's just the perfect person to have on there to keep students engaged. We really took our time finding the right person to be our teacher. It's funny, when we had all the first week, I had all these guys who are all phenomenal teachers, videotape themselves, record their lessons, and so we can go back and watch it. And then we brought Chelsea in to read the scripts, and it's just such a difference. We're professional educators, but some people are professionals on camera, and I think we all learned a little something there. So yeah, any questions about the content I shared with you?
Yes, just a quick one. What happens if they do stop mid-module? What will happen during that lesson then? And then how long is each module? Along with that, if they answer any of those self-check questions incorrectly, what happens then as well?
So there's a couple different ways we can set it up. To your first question, if they stop mid-module, as soon as they log back in, it's going to prompt them to either pick up where they left off or go back and review. And we can actually set it where it automatically kicks them back a segment of the lesson. I haven't decided if I want to do that or not yet. I kind of feel like because what if they just logged out for like 10 minutes and went back? So I think it's just going to be a prompt. And then we trust the learner, but it's recommended you go back and review. How long are the modules? So each one of the STEM lessons is between 30 and 40 minutes, a regular class. And that's an estimate. So, a student who maybe already knows the content is going to move through it a little faster, where if this is some of the content is a little bit more advanced, like say learning about what were some of the more complicated ones? Aerodynamics, for instance. That lesson might take a student a little bit longer. But we're average, we're guessing around 30 to 40 minutes. The building process, we broke it down so that way you're looking at between 10 minutes and half an hour. The last module, because it's tuning the bike, takes longer. That one's probably more like half hour to 40 minutes. Some of them, you're only adding a couple of parts. So there is some variation there. We wanted to divide them up more by the way you would build a bike actually, because there's reasons why you build it the way you do. And 2, conceptually, we wanted to put parts on that were linked together for a reason. So there's not like a set amount of time for each mod for the bike building process. It was more organized based on educational value. Does that answer? Okay, cool.
So just a couple of real quick observations. Okay, so what I said about the mind map, now I'm really excited because well, first of all, it's almost like you've captured some of our preaching and our I think my guys on the floor now have all of my various sayings sermonized. Oh, here comes sermon number 201. And I'll say you got to start with a uncluttered work area. Why do you got your headphones in all the time? It's not a safe condition. I like how you are reinforcing good work habits. That's a big one. Those are some of the soft skills a lot of employers complain about. Well, they're seeing lean, 5S, shadow boxing, all in your video. I'm assuming you meant it that way, but those principles are there in the video. One thing that's been in the back of our mind, because essentially for the capital region, we see ourselves as more of an urban company. We're going to be making an announcement in the end of this month where we're going to be expanding our facility here. And the disappointment to me, the the area where I think we have failed is we've made some inroads with women and with minorities, but not as good as what we would like. But I don't think that's just our failure. I think it's also the educational system. You are reinforcing a lot of that in your video just by showing images of girls engaged, with their dad, because those stories we hear is it's always the boy engaged with his dad and being the gearhead, right? So it's just a stereotype we've created. Yeah, we're making inroads, but we need to show more of those positive images. The other thing I like is that we're doing a lot of work with Brooklyn Steam down in Brooklyn, New York. I would be totally comfortable taking this, program and having them identify it with it right away. Not only because Chelsea's engaging, but because of the way the hands-on component meshes up so well with the principles, first principles. But what I really liked, what stood out to me is the reinforcement of some of those soft skills, because you'll, at least all these workforce development conferences I go to, you'll always hear employers say, yeah, but doggone it, the kids can't wake up in time or they can't show up on time. Okay, well, all that is being positively reinforced, and the importance of that's coming through in your video. So I'm assuming it wasn't by mistake, it was by design. So keep it up. And then seeing the interactive nature of the whole thing with video and the lessons, I can really see where this is going to be a powerful medium moving forward.
Thank you. And
Yes.
I'll explain where those two things come from. One, I'm a father of a daughter. And this idea came because my daughter loves to sit in the garage with me while I work on my bike, and she's always asking questions. And that's literally where this whole concept came from.
Yeah.
And when it comes to the soft skills, I'm a high school coach, and I've been a coach for over a decade. And one thing I've learned is that, the difference between a successful athlete and a non-successful athlete rarely has to do with their athletic ability. It has to do with how well they organize their life, their commitment. Are they, simple things? Are you drinking water? Are you getting a good night's sleep? That's led me to a fair amount of success as a coach. Those soft skills, those other things that I think they're so important.
Can I just add, go ahead, I'm sorry.
Go ahead.
No, I didn't mean to interrupt you, Jake, you want to roll there.
If you notice focus and effort, that's literally my mantra. If you ask any kid that I've coached, it's painted on the wall in my gym. It's on every flyer I hand out for all my coaching. Focus and effort, focus and effort. Those two words mean so much to me. So I appreciate you noticing that stuff.
Just two things I want to add in tandem with what David was saying when it comes to looking at this from a multicultural perspective, if you will, and looking at the diversity, equity, and inclusion lens that we're all working on, especially at WDI and in all of our workforce efforts, using the term soft, we're moving away from that and calling it now a foundational skill. Because if that foundation isn't set, if they don't have time management, they don't know how to communicate, they don't know how to break down and have communication skills, then that foundation, is crucial for them in terms of, building onto that. So yeah, you won't hear me use the term soft skills, it'll be foundational skills, because it's really important to have that solid foundation when it comes to workforce development.
That's an awesome point. And thanks for mentioning that, because frankly, every time I've said soft skills, I just kind of feel like soft. And rock solid, foundational, rock solid, perfect. I'm copying that one down. It's not copywritten, is it?
No, go for it, my friend. Please, Gary.
I'll use that in my next company assembly.
There you go.
So we have the perfect amount of time here at 9:40. Boys, I think I estimated 5 minutes. How are we feeling about 5 minutes here? Good? All right. I don't know. They're teachers, man. We love the sound of our own voice. That's how I ended up talking so much. I'm going to hand it off to my teachers. I'm going to let them each take a few minutes here to go through one of their modules. And you can ask any questions you have. Okay.
I'll lead off. This is always what happens anyways, right, Jim? I always talk first. So let me share my screen. I am presenting actually on module 3. Jake had it as module 3 right there, but we actually flipped them in the mind map. So what we're looking at is module 3, which is the front end. So in this part of the build, they're attaching the fork, the headset, the stem, and the handlebars to the bicycle. So Brian and I actually got to team up for a math and science lesson here. And one of the things we struggled with when we first started trying to create these lessons was making the educational parts as hands-on as possible. Like they're doing the hands-on stuff with the bike, but we want to make sure they're engaged in their learning, not just kind of passively watching videos and answering multiple choice questions. So what we came up here with was we're kind of doing a hook swallow lesson for the science aspect. And what we're looking at is that front shock. So what they're doing here is we have a video of us adding plates to the shock here, and we're measuring the force, and they're actually going to measure the compression of that shock so they can look at the linear relationship there between the two. So the video goes through and you can see us adding the different shocks on there. And what we're going to do for that video here is we're going to superimpose a ruler on there so they can measure the actual compression of that. So they're going to take and collect real data from that shock. And then eventually they'll compare the air shock to the spring shock. So you can see, like, here we go. We have nothing on, no plates on it. And then we add a plate, we can see it compresses a little bit more. So they're actually going to be able to collect that force and compression data to make that Hooke's law. So the idea is, in the science intro, we introduce them to, hey, let's develop an experiment that compares compression to force, right? Go and collect your data. And then in the math lesson, Brian's part of the lesson here walks them through what a linear relationship is, right? And so he kind of talks through what does a linear relationship mean? What is the strength of a linear relationship? If you weren't able to collect the data, you can compare yours to Brian's data, and then kind of try to fit that linear model to that data. And so then what they'll do is we'll send them the collect video on the air shock. So the shock on the actual bicycle is an air shock, but for mountain bikes, they also have coil shocks, and they have different relationships for that compression force relationship. So with the coil shock, it's a linear relationship, and the air shock, we actually get a curve here. So we allow them to compare those two models and then think about why and how they compare in real life for performance. So the math lesson then continues after they click the air shock data to look at different types of relationships. I'm just kind of flying through this because I have 4 minutes here and I'm already 3 in. And so collect the data, look at that fit, and then I believe I plugged in Brian's data. You can kind of see it's a curve here, right? That linear relationship doesn't really fit those data points, right? So they'll go through and kind of see that.
And that's interactive there. The students will actually have an opportunity to interact with those graphs. There's also videos with Chelsea in between here, and she'll be reading content while these are up. So Chelsea's in and out of the lessons, and she's also the voice of the teacher in these lessons. Sorry, Nate.
Right. Yeah, so like Chelsea would come in here with making sense of the graph. So like we'd say, okay, so you had found that linear relationship for the coil shock. Here's what it kind of looked like. Here's what all the aspects mean. So your slope tells you about the spring constant, right? That horizontal independent variable is the compression. That vertical variable is the force. And we can talk about what it means if you were to double the compression, that doubles the force, but you can only compress so far because you have a finite shock. And then talk about the difference between the two relationships. Oops, I guess I didn't take that note off, but Brian does have a graph for that because I showed it to you. You can see we're still drafting these, and we could talk, and then finally Chelsea would finish, what does it mean to be a Hookean relationship with that linear relationship versus non-Hookean? So it's kind of the content process there. I flew through it, but Jake gave me 4 minutes, so.
Great job, buddy. Sorry about the time crunch.
This is one module that probably might take more than 40 minutes. So we're going to have a natural stopping distance spot somewhere in there because they're collecting spring data, they're analyzing that data, learning about linear relationships, and they're collecting more data. So probably between that spring shock and air shock, we'll have a natural stopping point for them if they don't have enough time to finish it.
Brian, you want to go ahead? You have a different mod to show as well, right?
Yep, I have mod 4, which is on the crank arm. Let me share my screen. So as we were kind of going through this, the kind of hard part for me was are we basing the building of the bike on the lessons, or is the lessons based on the bike? And that was kind of something I had to wrap my head around. And eventually it was like, well, the goal is to build a mountain bike. So each time we're doing a module, the goal is to do the next process that a bike builder will do. So we kind of had to fit the math lessons to those set sections. But this is one of my favorites, which was on using the crank set to learn about radians. So they start off by, and one of the cool models of a radian is that it's if you wrap the radius of the circle around the outside of an object, then you get a single radian. And I was like, oh, let's just do it with string. And then you could put some string on the crank arm and show it. And then Jake's like, use parts of the bike. There's a chain inside the box. So what the students will end up doing, and I'll show you the video. I'll kind of walk you through it here. Can you still see this? Is the video showing up?
Yep.
So they start by using the chain to measure the radius of the crank arm. So it ends up being, and we got lucky, it ends up being about exactly 5 links. And then they wrap that around the crank arm. And then they choose a starting point. I told them to choose where the chain meets, just as a nice starting point. And then they knew that the chain was 5 links. So if they measure 5 links or 5 teeth around the outside, that angle formed. And we'll kind of add graphics in here. That angle that's formed between the red pieces of tape is 1 radian. So a lot of students think about degrees, 90 degrees, 180, 270, and 360. But when you're doing angular speed, which is what Nate's going to lead into, it's important to know radians as well. So 1 radian is created when you wrap those 5 teeth around the outside of the crank arm. And then if you keep doing this process, so they'll count 5 more teeth around the outside. And now we have 2 radians. And they'll do it one more time. And I tell them to do it get almost to a half a circle, and it's not exactly right. You can see I have 3 radians now, there's 3 angles. It's not exactly a full half a circle yet. That's because a half a circle is pi radians. So they can see that it's 3 plus a little more. So hopefully they remember pi from their geometry class or their previous classes. And they can say, oh, well, I know pi is related to circles and it's a little bit more than 3. So there's actually pi radians in half a circle. So there's 5 in each piece because that's the radius of the circle. And then we do it for the whole circle. Keep counting out by 5 teeth because it's there's 5 links in the radius.
And again, these videos will have recordings over them and interactions built into them.
And then now that they can see 6 radians have been made, there's a little bit piece on the extra, and that's because a full circle is not 6 radians, it's 2 pi radians, which is a little bit greater than 6. So that's why that little piece extra on the top right of the chain ring, because it's a little bit more than that. So then this is kind of a way to show, like, there's, a lot of times geometry teachers will just say, oh, to convert from degrees to radians, you just multiply by pi over 180. But this, demonstration shows why is 180 degrees pi radians. So then when I go into the conversions, they have a reason for, grasping that concept. It's not just like, oh, here's your conversion, here's your pi over 180, multiply and get the product. So they can go through these steps and know what the conversions are, but they have a reason for understanding that.
Yeah. Awesome.
And I'll tack on here. There will be questions periodically throughout, and also at the end of each module, beginning and end of each module, to really test and see what the students are picking up from each mod. Who wants to go next?
I'll go. Let's see. I had mod 6, which was the braking system. And so for the braking system, we of course have to talk about pressure. And so we begin by just looking at the pump that's in the kit, and they see the units down on the bottom. There's bar, and then there's also PSI. And that discussion of PSI is what we use to build this formula for pressure. So just by taking those units of pounds per square inch, we can talk about force per unit area. So that's kind of how we introduce that idea of pressure. And then we go through a fairly involved problem where they're given just the bare minimum of the initial conditions and a video of the bicycle wheel spinning and then being brought to a stop as the brakes are applied. And they can actually go through that calculation step by step, walk through it with Chelsea to find out the pressure that the brake pads are actually applying to the rotor to get that wheel to stop. So they would begin with the actual video and they can get information from that. Specifically, they can get a graph of revolutions versus time, which would tell you your initial angular speed. And then from there, we can get from that angular motion to a linear motion, then figure out the force that's applied on the brake pads, and then use that pressure formula to actually find out the pressure that the brake pads are applying. So they're walked through what is a fairly involved problem that gets down to this idea of pressure. So that's the first half of that engineering lesson. And then the second half is covering Pascal's law or Pascal's principle. So they're going to use that idea of pressure in this application setting where they're talking about something that's akin to like a hydraulic lift and showing that the ratio of the force to area on either side has to be equal. And then what happens if you apply more force to one side of this U-shaped tube, or what happens if you change, say, the area for one side of that U-shaped tube. So they learn about pressure in terms of the brake pads, and then what you can do with pressure to apply it to a system like a hydraulic lift. And I'm presenting in this mode intentionally so you can kind of see the mindset or the techniques, I guess, that we've been using for all of this. We've got our slides here, which are going to show what's actually in the videos. And then we've got our H5P prompts on the side. So those are the interactive questions that students are working with. And then down in the speaker notes, we've been putting the scripts, the actual words that Chelsea will read as well. So this kind of is a full overview of all the work that we've been doing, the questions, the content, and the script as well.
Thanks, Tom. Thanks for pointing that out. That's great.
I try to go quick for you, Jeff.
All right, Jeff, as
I'm
usual.
going to need as much time as I need. All right, let's see here. I'm like a Zoom novice, so bear with me here.
Very often the tech lesson ended up last, just the way it worked out. It's kind of like the culmination of information more often.
They just kicked me to the curb last. That was what happened. So, no, which actually worked out because as I kept telling Jake all year, I'm like, well, usually my projects and, lessons would be geared towards building the bike, but you've made that another module. So I had to really kind of think, kind of how to engage students. So I'm going to go with the module 1, which is where we start. We kind of talk about how the frame is built and the different styles of manufacturing products. And we kind of go through. I've got mine set up a little different. I actually made my H5P slides just slides so they stood right out because the comments were shrinking. But we are going to have video. We have the pre-questions, and then we kind of go into the different manufacturing types, which are continuous, batch, and custom. And we kind of relate all of those back to the bike. And I've also inserted some like custom specs of I mean, this is our bike, which as I found out from Jake yesterday, is just like a stock frame. But I mean, the fact that it's got the blueprint should help kind of drive the kids home. And, this is a custom product here. We have our H5P interactions to kind of keep them engaged. We talk about batches. And then we also talk about products that are just continually made and are just never stop or stop rarely to have stuff fixed. And I relate every single part of this back to the bike, so the kids know where the bike's coming from. So like the the bike's clear coat finish is something that's just going to be made in bulk and is then going to be sprayed on, and it's never ever going to be stopped. They just kind of keep on making that. Clear coat hasn't changed, at least what I've bought at the store hasn't changed a lot in the last 20, 30 years. We then kind of go into how the actual product can be made with forming, such as bending, stretching, deep drawing, and roll forming, as regarding making the metal tubes for the frame. We have videos of each. I'm still trying to find a good one for stretching. We then go into the difference between hot rolled steel and cold rolled steel, and what they're used for. As regards to product building, their pros and cons. We then go into how to separate products with lathes, mills, saws, drills, sanders. Those were the 5 I chose to list. There's a lot of other techniques of cutting and separating. And if I listed all those, Jake would be mad because he'd need about a 45-minute video. And I've got videos of this all happening to the bike. So I actually found some where people were actually cutting and making the different tube stock, and I related to the frame as much as I could, because at this point, that's all the students really have out. They have a kit, but they have the frame, which is out. So we then talk about different ways of combining, such as welding, fasteners, and glue. And again, I kind of skim coat it because I could talk about that for hours and hours and hours. So we're going to kind of go into that. I do put a focus on welding. Because that's one of the more common ones on the frame. And as we found yesterday, there's rather big welds on the frame, so they can't miss them. We then go into conditioning, such as heat treating, different types of thermoforming, in injection molding, and we just kind of go over all the different ways you can manufacture products and how they're all on the bike somewhere. I don't think there was one I couldn't find on the bike anywhere. And we end up with additive manufacturing, which is one of the newer ones compared to all the others. And then at the end, we have our summary and our post assessment. And that's kind of what we go through. And the kids would then go from here, and they would take their frame, and they'd be able to throughout this lesson, they'll actually be looking at the frame, making observations and answering questions.
It's great.
And I did that in 5 minutes.
Yeah, it's great. Guys, you did awesome. You all nailed it. We're right on time. Just to add to Jeff's point there, one of the things you notice is when he talked about the 3D printing of grips, we also offer, outside of the lessons that we've created for within the program, we have a long list of optional lessons that teachers or program leaders can then take and do on their own. So like Jeff had a great idea of a suggestion, like how cool would it be if kids designed and 3D printed their own grips for the handlebars. And so that's an optional lesson that we provide some resources for a teacher to then stop at that point and say, hey, if you have the ability to do so with the technology, design your own handle grips or actually 3D print them. Like over at Coxsackie Athens, we have the ability to do that. So that's something that would be added in. So guys, great job. I know that was real fast, but that's just kind of a couple lessons from various points in the program, and they're all that awesome. And you don't get the full feel of them yet because they're still in the process, but it's just really great stuff these guys are writing.
So can I throw it to David and Cricket just to get your take as to what you just saw?
I mean, from my viewpoint, I want to go back to school. Do this. I mean, I just think about how much time it could have saved me. to really have zeroed in on what I enjoy. But no, I think you're hitting on all the, so, you know, you talked about HVCC mechatronics 100 level course. That's part of how I got here because we had a graduate from that program. You know, we sponsor students in the advanced manufacturing skills program. And so we decided we're going to sponsor a student in the mechatronics program. We got that student here. He wound up getting a full-time position with Simmons, but in kind of debriefing him over the 3 years that he was with Simmons, and by the way, he's with an automation company in Brisbane, Australia right now, working there. He basically told us how ineffective the course, the entire program was, the mechatronics program. He had very detailed criticisms. I put those in writing. I submitted those to Hudson Valley, spoke directly with Roger Ramsamy, you know, all the people that I would normally have access to through the advanced manufacturing skills program. I tried to do it in a very constructive way. And I was really surprised how much they absorbed that information and took it to heart. I am kind of curious, like, how you got into that program, because based on all this, I want to send a note to Roger Ramsamy saying, thank you for doing this, because basically you've addressed every single one of my, I got to find that paper, but you've addressed every single one of the criticisms that we had about the program.
Well, that's great to hear, that we're on par with what it is you're looking to see change in these types of programs. Early on, I was a graduate of Hudson Valley myself. That was my first degree, was over at Hudson Valley. And I knew they had the School of STEM and these manufacturing mechatronics programs. And so early on, one of the first, call it a research call email I made was to John, who's the dean of the School of STEM. And I said, hey, I've got this idea. I'm working towards this. I'd love to know if there's a way that this could play a role. Maybe you guys could help guide us in, you know, how we should be developing this thing. And he told me, he said, well, listen, we're rewriting the curriculum for the mechatronics program, probably somewhat due to your letter. I wouldn't be surprised. And he said, why don't you sit in on our meetings and gather as much as you can? And, you know, maybe, you know, it sounds like a great idea. If it works out, then we can bring it in. And so myself and my business partner, Bobby, we did 7 or 8 meetings, a couple hours apiece. They shared tons of documents with us, and we learned a lot and found, you know, ways that we felt we could be most valuable to them.
Yeah.
So basically we just volunteered ourselves.
When do you go live with this for that program, or for that matter, with any program?
Sure. So we have 300 bikes coming from Taiwan this November. We're expecting all the online content to be done before the end of this year. It'll be beta tested in the late winter, early spring of 2022 at a number of high schools, as well as at Hudson Valley Community College. And then the goal is to be that first class in the fall of 2022.
Okay, great.
And we will, and as well as in some high schools, some after school programs. The Boys and Girls Club of the Capital District is buying a set of kits. They have, they're going to do an after school program with the STEM cycle. So we have a handful of ways that we're getting it out there. It's just a matter of gathering the data and making adjustments needed to make sure it's really ready for a full launch.
And I'll just piggyback on what Jake's saying, David, as it relates to Questar 3, because my hope here is that to get Jake and the teachers in front of our superintendents as we get into the school year, to present to them, just to highlight what they have been doing through the STEM research program, but B, to get the word out to these school districts to basically promote it. And Questar 3 is interested in going beyond our 22 school districts, because we can provide services and programs beyond our region. And we're looking to partner with Jake and his business to try to promote this statewide, if possible. And the thing I just want to throw out there is I've been saying ad nauseum to the teachers all summer about, my interest here is beyond that. is to try to figure out how we can connect businesses like yours into the classroom so that when they are rolling out this program and they're going through certain modules where there's relevancy or connections to the manufacturing processes, whether it's, you know, with a certain business or just in general, how can we connect a business so that a business could come in virtually, so to speak, and say, you know, talk a little bit about what they do and connect it to, okay, well, you guys are going to be learning about A, B, C, or D today. Here's how it's relevant to the work that we do. And so I'm just planting a seed with you. And I know that I've said this to Cricket. If you guys have any ideas as we're going forward, how I can be efficient in trying to get the word out there to you know, both make businesses aware of this opportunity and also to be working with us, because obviously at the end of the day, we're trying to facilitate collaboration and in addition to educating the students here and making them aware of opportunities around the region.
Yeah.
Absolutely. Yep.
And this is ground level, guys, here. Obviously, we're still in development. So if there are ways that you see maybe within our program, sharing content, you know, maybe there's a spot to make a video about what happens at Simmons Machine Tool and, you know, put that into our program somehow or connect you directly to the schools that, to students that will be partaking in this program. I'm all ears to types of ideas because I see real value in that type of.
I agree.
The
Okay.
seed has been planted, definitely. And Jim, one of your colleagues up north here at the Washington, Saratoga, Warren, the wishy-washies, if you will. We at WDI have been sponsoring a program that they do, their adult machine tool program, whereby just as, you know, you guys figured out, they were having all of their local area businesses looking for qualified candidates for employment. And everyone who came in through their doors did not have the skill set that they needed. And so rather than try to keep, you know, beating your head against a brick wall, which makes no sense, they called together all of those businesses, those industries to a roundtable discussion and said, what is it you're looking for? What is it you need in terms of for your employees? And they created a program that WDI funds every year for 18 to 20 individuals so that they learn specifically what is needed by the employers there. So this fits right in with that. And that continued thinking has to be in place. I mean, you can't continue to keep cranking out the same old because it's not working.
Yep.
Yeah.
Agreed.
Yeah. No, I just wanted to say thank you to Jake and your staff and the teachers there. Hey, you know, not to get too corny, but you guys you're on the front lines.
Yes.
I cannot tell you how much I appreciate all your efforts and creativity. Keep up the good work. Keep inspiring students out there. We need it. I'm fired up now. I'm on board, and I'll be thinking about, you know, what can I do in conjunction with you guys to kind of get out the gospel as well, so to speak. But yeah, I think there's a lot of opportunity here. My mind's racing.
Yes, this is very inspiring. You guys did a fabulous job. I mean, great way to start my Tuesday, if you will. Keep up the great work. This is just very, very encouraging, if you will, because, you know, without getting too off on a tangent, I'm concerned about our young people. I'm concerned about, you know, education. I'm concerned about, you know, the future of our work world, and programs, projects like these are just what we need to keep them engaged and to move us forward. So kudos.
Absolutely. Yeah.
Well, with that being said, we're a little bit over 10 o'clock. So I just want to say thank you to both David and Cricket for your time this morning joining us. And obviously Jake and the teachers, Haley, thank you guys. You guys did a great presentation. We look forward to wrapping this up at the end of the summer. And we will be keeping you guys abreast as to both what next steps are, as well as hopefully reaching out and, you know, opportunities to collaborate in the future. So.
Absolutely.
Okay. Thank you guys. Have a good day.
Thanks, guys. All the best.
You too.
Bye.